Have you ever wondered what would happen if water started gathering in space? A celestial body starting from just a few grams, but eventually becoming a colossal beast, many, many times more massive than our own sun. In this installation, we'll explore all the physical dynamics that occur as massive water grows from just a tiny droplet to a cosmic leviathan. Consider for a moment what determines the state of matter, the relationship between temperature and pressure. To begin our journey, we envision a glass of water. At first, it seems nothing could possibly be out of the ordinary. But all that intuition that served us here on Earth vanishes as we enter the cosmic vacuum. Because as soon as our glass of water enters the cold dark of space, it begins to boil. You see, pressure has just as much influence as its more familiar counterpart, temperature, on a given state of matter. It is the relation between these two parameters which determines the form which matter will take. Though this relation is one of opposition. Here, we have a graph putting that relationship on display for the substance that we are exploring: water. Temperature is more fundamentally known as a measure of kinetic motion on a molecular and atomic scale. Pressure, in this context, can be thought of as the amount of force applied to confine that kinetic motion. Due to the lack of pressure in the vacuum of space, water can freely boil, and the vapor solidifies into ice crystals. It's these resulting ice crystals that make up the composition of smaller objects like asteroids, meteors, and comets. Now, we'll consider the implications of increasing to moon and planetary scales. On these scales, we begin to see interesting dynamics. As our celestial body grows, reaching a radius of a few hundred kilometers, there exists enough pressure to create liquid oceans underneath a solid crust of ice. Real-world examples include Ganymede, Enceladus, and Europa. These are moons orbiting the gas giants in our own solar system. But now, we increase the size of our celestial body to a few thousand kilometers in radius. This is where we venture into the theoretical. A celestial body on the planetary scale yields enough pressure to create exotic forms of ice. These exotic forms of ice can exist at extremely high temperatures because of the extremely high pressures. That means there would in fact be a solid ice core at the center of our planet. The ice that would be at the center of this planet would not be the type of ice that you and I are familiar with. Referring back to the phase transition graph for water, we can see that ice is classified by Roman numerals. What determines the different categories for solid ice is the lattice for the atomic structure, or more simply, the way the atoms are organized within the solid material. Now, because our planet has a solid ice core surrounded by a liquid mantle and surfaced with a solid crust of ice, this allows the planet to have a magnetic field due to dynamo effects. Next, we reach a point where things begin to get extreme as we cross over into scales reaching stellar masses. At these intense pressures and temperatures, there's enough energy to cause instability in molecular bonds. This is the creation of the state of matter known as plasma. Plasma is a state of matter where electrons are no longer bound to the nucleus, but instead freely roam throughout all of the space between nuclei. It can be thought of as atomic nuclei within a soup of electrons. Eventually, temperatures and pressures become so extreme they reach a point of no return, igniting fusion. A star is born. But this star is not satisfied and continues to consume more and more. After consuming enough water to grow to a massive size of about 150 to 200 solar masses, an inevitable chain reaction begins while the star begins to collapse in on itself. The resulting cosmic explosion is called a supernova. From a boiling glass of water to a cosmic explosion. In this journey, we explored the incredible transformations that occur to a mass of water as it grows, highlighting just how powerful gravity and pressure can be. It is an ominous reminder of just how extreme the dynamic forces that shaped our universe really are.